Now let's talk about a triple covalent bond, since we have already spoken about single bond and a double bond. So what are triple covalent bond? Similarly, let's take example of nitrogen now. Nitrogen, or it is also called as dinitrogen. So dinitrogen is a covalent molecule which has a triple covalent bond. So if I draw the structure of nitrogen, it is something like this, isn't it? So let's talk about nitrogen now. So if we look at the structure of nitrogen or the atomic number of nitrogen, what is the atomic number of nitrogen? Atomic number of nitrogen is 7. So if I write the electronic configuration of nitrogen, it is 2 and 5. So how many electrons does nitrogen require to complete its octet? It requires 3 electron. It requires 3 electron. Hence, one nitrogen shares 3 electron, other nitrogen shares 3 electron, and that is how you will get nitrogen triple bond nitrogen. And this is why the nitrogen forms 3 bond, or it is also known as triple bond. I hope this is very clear to you. Now your nitrogen, I have already shown you that nitrogen forms a triple bond. So your atomic number of nitrogen is 5, or the atomic number, or we can say the valence electrons of nitrogen, the valence electron of nitrogen is 5. So 2 nitrogen share 3 electrons each to complete their respective octets, isn't it? So hence your nitrogen forms a triple bond. See in your diagrams, you can see the nitrogen has 1, 2, 3, 4, 5 valence electrons. So they require 3 electrons. So they combine with each other to complete its octet. And hence your nitrogen forms a triple bond. Now let's talk about covalency. What is covalency? Covalence is defined as the number of covalent bonds formed by an element in a compound, or the number of electrons shared. So simply number of bonds formed, we can say that number of bonds formed, number of bonds is equal to covalency. Number of bonds formed is equal to covalency. Simple as that. It is not any difficult concept to understand, correct? So let's see what are the different covalencies. If we take consideration of dihydrogen, so what is the covalency of dihydrogen? Hydrogen forms 1 bond. So covalency of hydrogen is 1. Similarly, you have dioxygen. Oxygen forms how many bonds? Just now we have seen oxygen forms 2 bonds. So the covalence is 2 in the case of oxygen. If we talk about nitrogen or dinitrogen, so the covalency in the case of dinitrogen is what? Correct, it is 3, because your nitrogen forms a triple bond. It is simple as that. It is not any difficult concept. So the element for which the second shell as mean the outermost shell, can have a maximum covalency of 4, as a second period elements do not have d orbitals to expand their octet. I hope this is clear to you. So for example of covalency, we can talk about boron. Boron shows covalency of 3 in BF3 and 4 in BF4. Nitrogen shows covalency of 3 in nitrogen and 4 in NH4. So if we draw the structure, NH3 is something like this, NHH. Then we have NH4, NH, H, 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 and there is a positive charge on nitrogen. So a same atom can show 2 different covalency. I hope this is clear. Similarly, oxygen shows covalency of 2 in H2O and 3 in H3O plus. So if I draw the structure of oxygen or water, it is the covalency here is 2, but in the case of hydronium ion, that is your H3O plus, here the covalency of oxygen will be 3, because oxygen is forming 3 single bonds. So fluorine and carbon can have maximum covalency of 1 and 4 respectively. So I hope this is very much clear to you. So the elements of which the third shell or higher is the outermost shell can have a maximum covalency of more than 4 as third period, and higher elements have d orbitals to expand their octet. Now these elements have d orbitals to expand their octet. The previous elements we had seen like BF3, they did not had any d orbital, they had just s and p orbitals. So in order to expand, now if we have d orbitals to expand, phosphorus shows covalency of 3 in P4O6 and 5 in P4O10. Sulfur shows covalency of 2, 4, 6 in its compound, because your sulfur can form 2 bonds. Sulfur can also form 4 bond, and sulfur can also form 6 bond, and hence the covalency can be 2, 4 and 6. Chlorine can also show covalency of 1, 3, 5 and 7 in its compound.